Hello, dear colleagues. My name is Nadia Mithatovna Galimulina. I represent Kazan National State Technical University, named after Ion Tupolev. I and my co-authors from Penza State Technological University would like to introduce you our study, MOOC in Physics as an additional resource for the fundamentals training of would-be engineers. Physics is one of the key disciplines situated by the curricula of engineering majors. Despite a sufficient amount of academic hours dedicated to this discipline at school and universities, it is necessary to expand the opportunities of applying additional learning tools, autonomous studies of the most important areas of physics. One of such tools is mass open online courses. Our study analyzed open online courses in physics provided by foreign, Coursera and edX, and Russian Open Education and STEPIK platforms. The criteria for analysis were the course's duration, the required level of training, the scope and content, as well as the features of pedagogical design of the courses. The demand for courses, number of learners, the universities developing them, and the language of teaching were also taken into account. Today, the issue of teaching physics at educational institutions is relevant and important. Undoubtedly, physics and its special areas are among the key courses significant for forming the theoretical basis of professional training of would-be engineers. During the recent years, there is a dismal decrease of the number of students taking the Unified State Exam in physics. At the same time, one can mark another trend. The average score of a Unified State Exam in physics somewhat grew in 2021 compared to the previous years. The distribution of the exam practitioners by scores and respectively by the levels of training demonstrated the increased differentiation of the results. The share of the participants who did not reach the minimal threshold increased, as well as the share of participants with high and very high levels of training. The above data reveal the initial level of knowledge of students who choose engineering as their future profession. At the same time, students of technical majors are taught physics rather deeply, judging by the numbers of credit hours in the curricular. For example, a bachelor course, Information Systems and Technologies, implies studying physics for 4 academic hours a week in the second semester and 3 academic hours a week in the third semester at Penza State Technological University, and 3 academic hours a week during the first 3 semesters at Kazan National Research Technical University, KAI. Mass open online courses are a tool of distant teaching, providing access to lectures of professors of world-leading universities, and the opportunity to learn when it's most convenient for a student, for example, in the evening after attending traditional offline sessions. For example, during the period of urgent transference to distant learning in spring 2020, 45% of students started using the materials of such distant courses after recommendations of their professors. To research the mass online courses in physics, We analyzed the learning content and the demand for the relevant courses at the most popular aggregators. For the analysis, we selected the foreign platforms Coursera and edX and the Russian platforms Open Education, Stepik, and Intuit. We have studied the English language and Russian language segments of the Coursera platform. The number of English language courses in physics significantly exceeds the number of the Russian language courses. 402 English language courses in the area of physical science and engineering against 334 Russian language courses. This analysis of teaching products excludes specializations courses and consultant projects. As one can see from the table, most of the courses imply an intermediate level of training and complexity of the materials offered. The courses intended for an advanced level constitute a very small part of the total number. The courses for beginners and mixed levels are about the same in numbers. These trends are characteristics both for English language and Russian language courses, as well as the courses developed by the Russian universities. The courses developers prefers the duration of 1-3 months. This does not boost the study of the new material and allows comprehending the offered themes at a comfortable pace. Shorter, 1-4 weeks, and longer, are the 3 months duration of the courses, depends on the amount of the material offered. Most of the English language courses are developed by the University of Colorado. The Russian segment of represented by the following universities: National Research Nuclear University, MIFI, Moscow Institute of Physics and Technology, and others. It is worth noting that online courses in physics at Coursera platform are very popular. The number of users of many of them exceeds 100,000 people. The English-speaking users mark the following advantages of the courses under consideration: a large number of complex experiments, which make the studied material more compelling and comprehensible, a large number of demonstrations, presence of brief and informative videos. These data confirm the general trend of the requirements to the content of online courses in physics and mathematics. So, about 60% of students mark the priority of demonstrating solutions to practical tasks in the respective MOOCs, while the importance of presenting theoretical materials was emphasized by 52.7% of learners. At edX platform, we found 5 courses in physics developed by the National Research Nuclear University, MIFI. 4 courses can be considered beginner level ones, 1 intermediate level. The duration of studies depends on the weekly load and equals about 1 to 3 months. At this platform, we found the total of 140 courses of physics category. Most of them were in English, and 1 in each of the Chinese, French, and Italian languages. Among the courses, the 50 beginner level, 54 intermediate level and 60 and 36 advanced level courses. The larger Russian aggregator of online courses is the Open Education Platform. It provides 54 courses in physics in the Russian and English languages. The developers are the leading Russian universities, National Research Nuclear University MIFI, over 20 courses, Lomonosov Moscow State University 4 courses, National University of Science and Technology 4 courses, and others. Stepik platform offers both classical and applied courses in physics, as well as specialized courses aimed at training school children for the basic state exam, the unified state exam, and contents of physics. They are courses developed by the individuals, authors, and collectives of schools, lyceum, and universities, the total of 21 courses. Most of the courses have a small user audience. Users mark interesting lectures aimed at development engineering thinking. At the same time, they make such defects as the attempts of some lectures to present a large material in a small period of time, some incorrectly formulated task, and an inflexible algorithm of submitting an answer. Virtually, all courses lack interaction with the developers, methodologists, and other users. Summarizing the results of the analysis of specialized MOOCs, one should note the popularity and high demand of online courses in physics. First of all, those developed by foreign universities and available at foreign platforms. Russian universities start to work actively in this sphere. The leader by the number of developed courses is National Research Nuclear University. When choosing an online courses in physics, it's more expedient to select large Russian and foreign aggregators to be confident in the study content offered. The courses with interactive tasks are great advantages as they more effectively provide basic training in physics. Successful mastering of knowledge in physics often depends on the opportunities to apply empirical methods of cognition. This leads us to the problem of transferring the classical sessions in physics, including laboratory tasks, into the content fit for online format. The content of the offered courses contains a number of problems: the lack of extra study materials, insufficient number of examples and problems for training and independent learning. The mass online courses under consideration cannot comprehensively solve the problem of transferring the learning of physics with all the relevant experiments and laboratory tasks into the internet environment. Full-fledged online laboratories require large expenditures, but introduction of such technologies would be fruitful for the efficiency of teaching physics in a distant format, which is especially relevant during the pandemic. Thus, mass online courses in physics cannot be considered to be a full-fledged substitute for traditional means of learning, but given due effort of instructors and hosts of MOOCs platforms, may help consolidating the material taught at university and deepen the knowledge in physics during students' independent work. Thank you for your attention.